Alright, welcome back. Now in this lesson we are going to program this conveyor system, which is quite easy. I know most of you know programming already, but just to fresh up the programming, we can do that very quickly. Okay, so we have already done most of the part. We have done the start and stop of the conveyor, and we have moved the speed from the potentiometer directly to the conveyor. Alright, now we have few more buttons here now. For example, we have forward, reverse, and we have some indicators, so we need to include that. We also have e-stop, so we need to include that in our programming of this conveyor. So let's start with what are the start conditions. So the start condition is you have to press the start button, and the another condition is we have to take care of the errors, and we also have to take care of the e-stop. Okay, so instead of having just one condition, which I will remove it, I will add multiple conditions. So in that case, to have multiple conditions, I use AND logic. Okay, so I just drag it here in between these two. I can do it here. So automatically my start is here. Now the second condition for the start button is that the stop button should not be pressed. Okay, and stop button is my NC. So that should be true. So I will not take here NC like here. So I just take here the stop button like this one. Oh, NC like here. So this one is the stop. So if stop is not pressed in the machine, in the panel, if this is not pressed, this is already true. And this is an AND logic, so I will not take here not like here. So this should be okay. So this is the second condition. The third condition is about e-stop. Okay, and the e-stop, we can see the addressing of e-stop from our data block, and this is in the input. So if I show you that e-stop is already true, which is good, take it here. Okay, e-stop when not pressed is true, stop button when not pressed is true, so both conditions come here in the AND logic. Okay, and one more thing, we have to take care of the error common, which I told you we will use it. So if there is any error, it will not start the conveyor. We don't want to start the conveyor. In case of error, we have to remove the error and then we have to start. So the error comm will also come here. So if there is any error, this will be true, and this should be false in that case. So we will take an NC here of the error. Okay, because error comm will be true when there is an error, not like e-stop and normal stop. So I took NC here. So these are the four conditions for start logic. Similarly, we have condition for the stop logic. So it should stop the conveyor when the stop button is pressed. It should also stop the conveyor when e-stop is pressed. Okay, so similarly, I will take an AND logic and put it here. And here comes the e-stop. Now the e-stop is an NC switch, just like the stop. So I will take here NC. And because this I will remove basically and put the NC here. So they have individual NC and it's quite easy to understand. So I will put e-stop here. So when both are false, which means when any of them is pressed, this will be true and this will be true. And here instead of AND gate, we'll take an OR gate. OR gate because this is an OR condition. If this is pressed, this should be stopped, this should be reset. Or if this is pressed, this should be reset. Or if both are pressed, obviously they should be reset. So I took the OR gate. Okay. And one more thing which will stop the conveyor is the error. So although we have took it here, we will also take it here in error common. So if there is any error common, it will also reset the start bit. So start and stop conditions are defined. And let's just check this logic and then we will proceed to the next part. So going to download now. Load. Perfect. So you can see that this is true, this is true, this is false, so it's NC is true. The only thing which needs to start the conveyor is the start button because there is no error and no EM stop is pressed. So I can again go back here and I can start, give some speed, I can start my conveyor and I can stop from here. Or I can also stop from here. Okay. Now this is pressed. If you notice, this is pressed. So one of the condition got false. So I cannot start anymore because of my logic. So I have to release it and then I can start it. I can also simulate the error. Oops. If I open TIA Portal, now if my error common is true, so let's make it true. Now error is true. Although I don't have error in the conveyor, this is just for simulation. I cannot start my conveyor because I have to remove the error. Okay, so I will go back and make it false again. And now I can start my conveyor. And similarly for the stop, let's try that again. This is running and eStop will stop it. It is running. Stop will stop it again when it's running, and also the error can stop it. So when it's true, this is false, and when this is false, conveyor is stopped. Okay, so I hope this part is clear. Quite easy. I'm sure you know it already because you have been to the first lessons of the course 1. Anyways, now coming to the second part. Now here is a bit tricky because we have a selector switch which we can move reverse and forward, and based on that we have to convert the speed into minus. Okay, with reverse it should be minus 6.2, with forward it should be plus 6.2. Let me explain you. If I'm moving forcefully, the conveyor is 6.3 running in one of the direction. You can see this is clockwise, and if it is in minus, it is running anti-clockwise. Pretty nice. So we know the concept how this conveyor is running. Maybe you have a different concept, but if you are learning programming, we will use this concept. So I will release the force. So how we can do that? I would like to go back to my read block and let's see what we are doing. We are reading the speed from the potentiometer into the input speed, and then we are moving the input speed into the parameter speed. So what I need to do is I will like to make bit changes here because this will make understanding more easy. I would like to move the speed from the potentiometer directly into the parameter. Okay, so I will basically cut this one and paste it here. Okay, so let's say I will just put a comment: reading speed input from potentiometer to parameters. Now why I'm doing this? Because I want to display this parameter speed into my display here, and because this display cannot show in minus, that's my limitation because of the software. I want to use float, or maybe I can use integer. In the float I cannot use minus, it will only show in positive. That's why I'm doing it. And also another reason is we have to use a switch to basically do multiplication with -1. So what I'm going to do next is we have to define, so we have moved, initially the first step is move the speed from the potentiometer to parameter directly. All right, so now we know that our speed is in the parameters. Now we will define in the drivers the forward and reverse. So forward is I0.3, reverse is I0.4. So let's go back and we do the same step we did in the first lessons, because we have now more inputs. So I will try to add it here. So this is I, X, forward. So this is Boolean. This will be I0.3. Okay, and then comes another one, input, X, reverse, which is I0.4. Perfect. Now we need to read these inputs and do the same step, move into data block. So first we define in the data block 2 more inputs. So this will be input and Boolean, forward, input, again Boolean, reverse, and that will be Boolean again here as well. So we have 2 more inputs, we know that. Now dB has been defined. Second step is we have to read this input here. So I will write, first I will take dB, forward and reverse, assign So let me close it now. So forward, come here, reverse, come here, and now our DB is getting the value of forward and reverse. If you want to check it, Conveyor DB, we can download. I'm doing it because we want to proceed step by step. So let's load it and basically open the other DB, not this one. Download it. Data block. Okay, we can open all the fields. Now let's just check it. So you can see that forward is already true because it is here true. And I go to reverse. Reverse is true. And well, now forward is true. So our DB, which should get all the values, is getting the values. Okay, going back to our reading inputs. Now what we have to do is, if our forward is on, then I will move this parameter. Wait a second, this IR speed is going to the parameter, yes. Then I will move this parameter into, where is the block? Into IR speed here, input speed. Okay, so we have an if and else statements now. So let's take the syntax of if and else. If you're not familiar, you can do that if. Okay, now if, what is the condition of if? So let's take here condition. We have condition as an input. So I'll write here x forward is my condition. So we can also take only x forward, or we can also take x reverse. So let's take x reverse. Now the condition is if x forward is true. So if x forward, you can just write like this. You don't have to write is equivalent to true, because this is also possible. This also makes sense that if x forward is true, or you can also write equivalent to true, but I prefer to leave it like this. If this is true, then we are going to move. This will come here. This will get the value from the parameter. Copy, paste. So if forward is true, whatever parameter value has from the potentiometer, it will go to the input parameter, input speed. And in the logic, if I go back to here, we were moving parameter. We're gonna change it. We will move, instead of parameter, we will move IR speed. Now you will understand it. Pretty clear. So if forward is true, if forward button is on, whatever is it in the parameter will move to the input speed, which means it's the same coming from the potentiometer. There's no negative term in that. And whatever is in the speed will go to the output. And what is in the output will go to the output tag later on. So this was when there is only forward button is pressed. Okay. Now we will copy this, make it easy. In case if we have reverse, so I will make it reverse. Whatever is in the parameter which is coming from the potentiometer, multiply by -1. So instead of that, I will put a bracket. Multiply by -1. Oops, not x, sorry. Multiply by -1, and then it will go to the speed, and whatever is in the speed will definitely go to the output, because that is defined here. So I hope this program should work. So let's try to download it and check it. So this was about forward and reverse control. Oh, we have some errors. Okay, we have errors because, oh, my bad. I have to update this logic. So I have to mention what are the forward and reverse buttons here, which is in our data block. So my forward is coming from here. Reverse is coming from here. Remember that this forward reverse is from the data block, which is reading the value from PLC, from the PLC tag. This forward reverse inside it, basically, wait a second. Yeah, this, what is inside is, this inside is the forward reverse defined here in the function. Okay, must consider that. So rest of the logic is same. So let's go and download it. There can be multiple ways of programming it. This is not like you have to only follow me. But in this lesson, what we are trying to understand, we are not learning programming. We are learning how to structure your data, basically. So let's just try this once a time. So I have this, this is positive, and if I make it reverse, this is negative. So our logic is working. So let's just try now. Oh, strange. Okay, just click it. So I'll start the conveyor, and the speed you can see is 6.2. And let's make it reverse. And now this is minus 6.2, and you can see this is running in reverse. So you can also increase the speed. This is maximum speed now. This is in forward, and that's in reverse. If you want to just confirm, this is anti-clockwise, and that's clockwise. So we have just seen the first part of the programming, how to change the speed, and we have also seen how to stop the motor, start the motor, and do the direction as we want. So if this is already at reverse, this will start in reverse. Okay. Now the second part is we have to make sure we have some indications on our machine. Alright, so this video is becoming very big. I will split it here, and in the next video we'll see how to get the indications on the display and on in the stack light. Alright, so see you in the next video.